Ever wondered how Docker simplifies the process of managing application processes in containers? Well, let's embark on this enlightening journey together. Docker, in its essence, is a tool designed to streamline the process of creating, deploying, and running applications. It achieves this by using containers, which are lightweight, standalone, and executable packages. These containers house everything an application needs to run, including the code, runtime, system tools, libraries, and settings. In today's software development landscape, Docker is more than just a handy tool. It's an essential component that reduces the "it works on my machine" syndrome by providing a consistent environment from development to production. It also simplifies the process of setting up and managing microservices architecture. In a world where efficiency and consistency are paramount, Docker emerges as a game changer. But to appreciate the full magnitude of Docker's power, we need to delve into its architecture. Scene script. Docker's architecture forms the backbone of its functionality. But what does it consist of? Well, at its core, Docker's architecture is built around three major components: the Docker engine, Docker images, and Docker containers. These three elements work together in harmony, creating a seamless and efficient environment for deploying and running applications. First, let's talk about the Docker engine. This is the heart and soul of Docker. Think of it as the powerhouse that drives everything else. The Docker engine is a client-server type application that consists of three main parts: a server, which is a type of long-running program called a daemon process; a REST API, which specifies interfaces that programs can use to talk to the daemon and instruct it what to do; and a command line interface client. Moving forward, we have Docker images. Now, what are these? Simply put, Docker images are read-only templates used to build containers. They are the building blocks of a Docker container. An image includes everything needed to run an application: the code, a runtime, libraries, environment variables, and configuration files. Images are created from Docker files, a text file that specifies all of the components that are included in the image. Last but not least, we have Docker containers. If Docker images are the building blocks, Docker containers are the end product. Containers are a runtime instance of an image, what the image becomes in memory when executed. They are lightweight, standalone, and executable packages that include everything needed to run a piece of software, including the system tools, system libraries, settings, and so forth. To sum it all up, the Docker engine creates Docker containers from Docker images. It's a process that works together like a well-oiled machine. The engine uses the information and instructions in the image to deploy a container, which is then ready to execute and run your applications. And there you have it, the Docker architecture in a nutshell. It's a system designed to make deploying and running applications easier and more efficient. With these three elements, Docker creates an environment where applications can run efficiently and reliably. The heart of Docker's architecture is the Docker engine. But what role does it play? Now imagine Docker engine as the heart in the body of Docker. It's the runtime that builds and runs containers, a kind of life-giving force in the Docker ecosystem. At its core, the Docker engine has two main components: a server and a client. The server, which is the part that does the heavy lifting, is a long-running program called a daemon process. This daemon creates and manages Docker objects such as images, containers, networks, and volumes. On the other hand, the client is how we as users interact with Docker. It's our gateway to the Docker engine. When we run Docker commands on our terminal, it's the client that communicates with the server to carry out these commands. In essence, the Docker engine is a powerhouse, a vital cog in the Docker machine that drives Docker's functionality. With it, Docker can efficiently build, ship, and run applications as portable, self-sufficient containers. The Docker engine is the powerhouse that drives Docker's functionality. Docker images and containers are the building blocks of applications in Docker. How do they function? Let's dive in to understand these core components. Docker images, at their simplest, are read-only templates with instructions for creating a Docker container. Think of them as a blueprint or a recipe, detailing what software, libraries, and dependencies are needed for an application to run. When you pull an image from Docker Hub or create your own, these images are stored locally on your machine, ready to be used to create containers. Now, what are Docker containers? Imagine them as the living, breathing instances of Docker images. When you run an image, Docker takes that read-only image, adds a writable layer on top, and creates a container. A container is a runnable instance of an image, encapsulating an application and its dependencies, all bundled up in its own neat, isolated environment. But why are these two components so crucial in the Docker ecosystem? Here's why. Docker images ensure consistency. Regardless of where they are run, they produce the same environment. This eliminates the age-old problem developers face, but it works on my machine. With Docker, it'll work on any machine. On the other hand, Docker containers provide isolation. Each container interacts with its own file system, networking, and isolated process space. It's like having your own private island, unaffected by what's happening elsewhere. This means you can have multiple containers running different applications, or different versions of the same application, all on the same host, without any conflict. So in the grand scheme of Docker, Docker images and containers work hand in hand. Images provide the blueprint, and containers bring that blueprint to life, allowing you to build, ship, and run applications anywhere and everywhere. And that's the beauty of Docker. It's like a well-oiled machine where each part plays a critical role. With Docker images and containers, you've got all the ingredients to create and run your applications. Docker's architecture might seem complex at first, but it's all about simplicity and efficiency. We've journeyed through the intricate structure of Docker, starting with the Docker engine, the heart of Docker's operations. It's the powerhouse that manages Docker images and containers, providing the necessary environment for applications to run. Then, we delved into Docker images, the read-only templates used to build containers. These images are the building blocks of any Docker-based environment, providing the necessary instructions for Docker to create and run a container. We also explored Docker containers, the executable packages that encapsulate an application along with everything it needs to run. They are amazingly lightweight and efficient, providing isolated environments for applications to run without any conflicts. Understanding Docker's architecture is not just about knowing these components. It's about realizing the power of containerization, about harnessing its efficiency, and about leveraging its simplicity in your software development process. With a solid grasp of Docker's architecture, you're ready to harness the power of containerization in your